Hello everyone. Welcome to Codecast, and today we'll see the topic Langgraph, and we'll see like why it's important, what are the core concepts, how it differs from LangChain, and why should we use Langgraph, the key components of Langgraph, the Langgraph with agents and memory, execution modes in Langgraph, use cases, benefits and limitations, and then we'll see the implementation part of the Langgraph. Now, starting with Langgraph, it is about building stateful multi-agent workflows. We can build multi-agent workflows using Langgraph, and we'll see with the introduction and what is Langgraph. So, it is by the definition, if we see, Langgraph is an open source library that extends LangChain to build stateful multi-step AI workflows using a graph-based structure. So, using Langgraph, as it is an open source library, it led to create stateful multi-step and branching workflows for LM using a graph-based architecture. Now, it builds on LangChain and it allows for complex reasoning patterns also, and such as loops, conditional flows, dynamic decision making, stateful agents. So, multiple things are involved in LangGraph. Now, we'll see why it's important. It supports memory, loops, and branching, ideal for complex tasks involving multiple decisions, and it is great for building agent-based systems with flow control. So generally in modern AI applications, which are multi-step, not just input and output, interactive, need reacting or confirming, and it is stateful also, which require memory between steps. And LangGraph solves this by giving structure to the LLM workflow. So this is the most important one. LangGraph basically gives structure to the LLM workflow, and it manages state, routing, and conditions, letting you build reliable and testable system. So this is the importance of LangGraph. And moving on, we have the question: have you ever needed an AI to remember, decide, or go back a step? So generally, in many cases, we need an AI which remembers our previous conversation. We decide, and we need to go back to a step. So at this point of time, LangGraph plays an important role. Now we'll see the core concept of LangGraph, which is a graph-based workflow. Now, LangGraph is built on the idea of a computational graph. So there are multiple concepts, core concepts involved here. First one is the node. That is because in nodes we can have the LLMs, we can have tools or actions. Then we have the edges. That is the flow of information or control between the nodes. Now, if you compare or consider the concept node, it is a function or LLM step also. For example, we need summarization or validation. At that point of time, node plays an important role. Next one is the edges. It is the connection between the nodes. When there is a connection between the nodes, we call it an edge. And another one which we have is the state. It is a Python dictionary basically that holds memory and is passed between the steps. Next one is the graph. That is the collection of nodes and edges defining your LLM application flow. Now it enables looping, retrying, condition checks, and more. Unlike linear chains, LangGraph lets you create flexible dynamic pipelines. So looping is involved. We can have multiple loops here. We can retry if the answer is not correct. We can have the condition checks. We can have the if else condition like state in the LangGraph, and it is and more things are also involved in LangGraph, but these concepts are not involved in linear chains. And so LangGraph plays a very important role when we need such conditions, and it lets us create flexible as well as dynamic pipeline. How LangGraph differ from LangChain chains? Now, previously when we are using LangChain chains, and now we are studying the LangGraph workflows, we'll see the differences. What are the key differences according to the structure, flexibility, looping, and branching, and what are the best use cases of each one as compared to chains and LangGraph. In case of structure, LangChain chains are linear or nested, and in case of the LangGraph, we have the graph base, that is, we have the node and we have the edges. Flexibility is limited in LangChain, and in case of LangGraph, it is highly customizable. In case of looping and branching, it is not supported in case of chain, and which is much more important when we have a complex task. Whereas in LangGraph, it is fully supported, so it can make our process more dynamic. Now, the basic cases are simple tasks. Case of LangChain chains, we use it for simple tasks, and whenever the complex decision making is involved or multi-step decision flows are involved, at that point of time, we use the LangGraph. Now, why might a graph be better than a straight line for complex decision? As in complex decision, we have looping, retrying, then in case of retrying, if your conditional statements are also there. So at this point of time, complex decisions are involved, and at that point of time, graph plays an important role rather than the straight line. So in this way, how we have seen the differences, how LangGraph differs from LangChain chain. Now, why use LangGraph? Now, it is best for multi-agent coordination. We can have stateful memory between steps. We can involve memory by using a simple dictionary, which is called as state. And we can also have the tasks that require try, revision, or approval. So all these tasks are being covered under Langgraph. And we also have the real world automation. We can do AI writing plus reviewing plus posting. Now we build robust AI workflows that can re-app, retry, or verify steps. At that point of time, we need to use LangGraph. When we combine LLM plus tools plus memory plus human input, at that point of time, we need LangGraph. If we are if we want easy support of if else for loops and error handling, at that point of time also we use LangGraph, and it integrates with LangChain agents also, vector store. And so as the coordination is there between all these components, we can always prefer LangGraph or LangChain chain. Now we can think of LangGraph as an AI workflow engine. So if you want to imagine LangGraph, we can see if multiple agents are involved, multiple tools are involved, and there is a complex decision making. So at that point of time, we always prefer LangGraph, as it is more about looping, retrying, and using multiple tools or combining different components like LLM tools, memories, or human input. And if we want to use if else or for loop condition, at that point of time, we should always use LangGraph, and we describe it as the AI workflow engine. Now we'll see the key components of the LangGraph. First one is the node, single step in the process. Example, generative response. Now, node can be a LLM, can be an agent also, or can be a custom function. So that is about the node. Then when we consider the edges, it connects steps and define the flow. We can connect different nodes, and when there is a connection between two nodes, we call it as an edge, and it can define the flow of our LangGraph. Now, in case of state, we keep the memory and variable between the steps. So whenever we want to store the previous conversation, and at that point of time we use the dictionary for storing those, and they are called as state. It basically acts as a memory and variables between the steps. And last one is the graph, that is the overall workflow defined by the node plus agent. Now the question we have, guys, is how does state help an AI system make better decisions? So discuss this question among you, and we'll also discuss in the this question and get the best response in the next section. Now, when we consider the key components of Langgraph, we have node, we have edges, we have conditional edges, and we have state. Now, in case of node, we have seen it represent individual agents, each with a specific role. These agents might be responsible for planning, executing tasks, reviewing outputs, or utilizing specialized tools. So, node can be an agent, can be a function, can be an LLM. So, this all part is cleared by the node part, and then we have the edges. When we want to connect different nodes, now we can have multiple agents here. So if multiple agents are involved, we have multiple nodes. And if you want to connect this node, then we have when there is a connection between two nodes, we have edges. The edges represent the dynamic connections between the agents. These connections adapt based on the context, enabling the system to cycle information through different agents as needed. So if we want to also give the if else conditions for different nodes when we want to execute a particular task, if a condition is satisfied, at that point of time we use the conditional edges. Conditional nodes are a decision making points within the graph where the flow of execution is determined based on specific condition or criteria. So whenever the conditional edges are involved, we will get the more appropriate answer according to our question or the user query. Now when we consider the state, it is the memory of the previous if you want to show the previous conversation of the user and the previous conversation or history of the output we got from the node. So at that point of time, we use the state, and which can be passed between the nodes in a whole graph. If you want to pass the output of a particular node to the next node, at that point we need the state. So these are the key components of Langgraph. Hope you guys understood it. Now we'll see Langgraph with agents and memory. Langgraph integrates smoothly with LLM agents, just like we did in QA. We can have multiple LLM agents, and we can integrate all those by using the Langgraph. Now we have the memory module for conversation or task history. We can store previous conversation or the task performed by the previous node. So at that point of time, we use the memory. It also integrates smoothly with external tools like the Flair calculators or APIs or the like previously we have seen the SERP API. So we can also connect the external tools here and memory modules as well as LLM agents. Now agents can act, observe, decide, and do try based on feedback from other nodes. Now, whenever a particular node is executed, that means if we are using a particular agent in a particular node and after getting the output from that agent, we can, the agent basically act, observes and decides and retry based on feedback which is provided from the previous node or the other node. Now, the execution modes in Langgraph, we can have the sequential one. Now, you can run Langgraph workflows using the sequential, which is from start to end. Then we have the conditional one, which is the logic based part, just like if else condition. We have the recursively, which is looping until success or max retry is done. And we also have in parallel, just like you can imagine the parallel processing. So multiple agents or multiple nodes work parallelly, where tasks don't depend on each other. Whereas we compare the sequentially, they depend on each other from start to end. So that is not the case in the parallel one. They are independent enough to work on their own task. Now it is more like a decision tree than a simple function call. So you can imagine if we are using the just like in decision tree, the if else conditions was involved. So we can imagine Langgraph also in the same way. Now with cases of Langgraph, now practical examples are document review. We can generate a particular document, we can check, we can edit it, and then also if we are getting the right document, we can approve it. Now chatbot with fallback, like we have answer, then ask user, then escalate. We also have autonomous agent system that does the researching task plus writing plus fact-checking the answer. We also have the AI pipelines where we need to plan, we need to execute, evaluate, and retry. Now, which of your projects would benefit from a workflow like this? Whenever complex tasks is involved, remember guys, we need to use LangGraph for multiple agents so that the workflow is quite if we need sequential approach, we can use sequential approach. If we need parallel approach at that point of time also we can use it to Langgraph. Whenever we need the what we can say is looping is required for getting a particular answer at that point of time also we can use Langgraph. So use cases are multiple, whether you are building an chatbot or whether you are building an AI pipeline or document retriever or document reviewer or autonomous agent system. Any project which has complex tasks or involves if else conditions or looping at that point of time, we need to use Langgraph. Now, benefits and limitations. We have full control over the logic, all over the logic building between the nodes and edges. We have the full control. We have memory between the steps for storing the output of the previous nodes and passing it to other nodes. So we have memory for that. We have set memory. We can have error handling is there also, and we can also retry. That is one more benefit. They have agent collaboration support. As collaboration of multiple agents is involved in LangGraph, and each agent represents node. So collaboration is easily when we connect them with each other. Now limitations, it is more complex than chains as we are building a connection and we are creating a graph-based structure. If multiple agents are involved, so it is more complex than the simple chain. Now it requires good planning of flow. So planning is much more required. Which node will pass the output to which node and how the output of a particular node will go to a particular node. So if else conditions are all also involved in this such cases. So proper planning should be required while building these nodes and edges. Now it is best suited for advanced workflows as in real world applications, complex tasks are involved and we cannot use line chains and much simpler tasks are not involved in the real world application. So more we use the Langgraph, we can get the complex decision making better here. So when we have the advanced workflow, we'll use the Langgraph, while we have the simple task, we'll always prefer the LangChain chain. Now we have a tip here you can use for tasks that need reasoning, checking, and iteration. And these are the basic what we can say components which are used in the advanced workflows. That is the reasoning, checking, and iteration. So for real world applications, mainly we use Langgraph. Now regarding the summary, what we have learned up till now is Langgraph lets you create a graph-based AI workflow, and it supports state, memory, and multiple agent coordination. It is ideal for dynamic as well as real-world decision heavy tasks, and it is more flexible than traditional LangChain chains. So these are the key points or the key takeaways we have learned from the previous slide. Now you are building an AI system that answers customer queries but escalates to another bot its confidence is low. How would you structure this in Langgraph? So I need you guys to build AI system which basically answer the customer queries, and according to the problem statement, I want to see and use it to your own use case and structure the line graph here. Now the question, what one task where you would want the AI to retry or loop until it gets the better result. So discuss this among yourselves and also try to research this question, and we'll discuss this question also in the next section. And we'll now move towards the implementation part of Langgraph. Now see the implementation part. First of all, we'll import the API keys in case we need it. Get OpenAI. We'll import this keys in environment. OpenAI API. We'll install the LangChain community and also OpenAI. Community and OpenAI. We'll install the Langgraph now. Wait, install Langgraph. Now from Langgraph and graph dot graph input graph. Now, first of all, we'll build two functions here, and we will consider these two functions as two nodes here. So first of all, we'll start with the function. Left function one, one, and we'll pass some input here. Input one. We'll return input one plus we'll describe it uh, as a first function. So first function, okay, and we'll create another function 2, and we'll pass input 2 here, input 2, and we'll return input 2 plus that it is a second function, right? Now we'll see if we pass function 1 and we say Virat. Okay. Now we have built the two functions. Now we'll try to convert this function into nodes, and from nodes then we'll connect these two nodes, and when we connect these two nodes, it will be a edge as there is connection between two nodes, and we will see how we can execute this graph based structure. Now first of all, we'll mention the graph equal to graph, right? And then we'll add node graph, add node. We'll mention it as function 1, and we'll mention the function name here, function 1. Okay. In this way, we can add node graph dot add node, and we'll mention function 2, and we'll name the function called function 2. Now we have added node. We have added two nodes, function 1 and function 2. Now we'll connect these two nodes, and for that we'll need graph dot add edge. We'll mention the name now. We have changed the name of the function. When we change the function to function 1, for considering it as a node, now we'll mention that name. It is the function 1. We'll not mention the function 1 and function 2. Okay. Function 2. Now we have connected these two nodes here using add edge. Now we'll set the entry point. We'll set the workflow of the graph, that which will be the entry point, which will be the finish point of which node. So For that, we need set entry, set entry point. Now, our output should flow from function 1 to function 2. So, we will set entry point as function 1, and our finish point will be function 2. That finish point will be function 2. Okay. Now, we have mentioned the workflow of our graph. Now, we'll compile it. So, graph.compile. Now, we'll see the workflow of our graph, which we have built now. For that, we need to mention python dot display import image 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 app dot get graph, and we'll mention draw moment in view. We will run again. We are getting error here. Till then, we'll see how our graph look like. Get graph. We will see the now as you can see here, we have the function 1 and function 1 data function 1 tag. So this is the theoretical version of how our graph will look like. Now we'll build another function. Now first of all, we'll see the definition node, which is in Langgraph node in Langgraph node can be a function or chain that we can run. We also have special types of node. Special types of node. We have the start. This node sends user input to the graph, and we also have end. Like after this node, no other node can run. No other node can run. And we also have seen. Now we also have edges here, so we'll see the edges. To connect different nodes. When we connect two nodes, when there is a connection between two nodes, we have a edge. So that is basically the edge here. Now we have normal edge here. Normal edge, that is add edge, right? We were using add edge, and which is from and to. So previously we had mentioned here add edge function 1 and function 2. So from and to. Then we have the conditional edge. Conditional edge, where we will add conditional edge, where we use from, to, and the condition mentioned here. So this is the conditional edge, and we also had seen the set entry point. We will see that set entry point, which is it should determine which node will get the user input. User input, and then we have the set finish point, and we mention the node also here, which will determine when to finish the graph execution. To finish the graph execution. So these are the components we use in Langgraph. So I've run this cell which we are getting error earlier. So we had built the two functions and we had added these functions towards the node, and we had built the edges, that is the connection between the two nodes, function 1 and function 2. We set the entry point as function 1 and set finish point as function 2. And when we see the get graph through drop mermaid PNG, we can see we got the start, then we have the function 1, then we have the function 2, and then we have the end. And this is the theoretical version. We have also seen the definition of each component of the line graph. And hope you guys understood how basically the line graph works. And if you understood, please like and subscribe our video. And we'll see you in the next video. Till then, bye.